So today we will be solving this problem called the Tower of Hanoi. It is a very famous puzzle, and this puzzle consists of three stacks, left, middle and right, and we have n round disks of different size initially. The left stack has all the disks in increasing orders of size from top to bottom, so something like this. We have three three stacks, and the leftmost one has all the disks from smallest to largest, and the goal is to move all the disks to the right stack using the middle stack, and on each move you can move the uppermost disk from a stack to another stack. In addition, it is not allowed to place a larger disk on a smaller disk. So our task is to find a solution that minimizes the number of moves. So just to make things clear, in each move we can take the uppermost disk of any stack and move it to some other stack, given that the uppermost stack is larger than the uppermost disk in the destination stack is larger than the disk we're gonna put on top of it. So for example, if we had a situation like this, where this was small and this was large, so we cannot take this disk from here and put it on top of here, so this is not a valid move. But besides from that, we can always take the uppermost disk and put it on another stack if that stack is empty, or the uppermost disk on that stack is larger than the disk we want to put on top of it. So this is pretty much it, and they want us, so the goal is to move so our task is to find a solution that minimizes the number of moves. So n is up to 16, and we need to print k, the minimum number of moves, and after this print k lines that describe the moves. Each line has two integers a, b. You move a disk from stack A to stack B. Great. So let's try to come up with a solution. Here, if we look at this problem, let's try to make an observation. So no matter what we do, in order for us to move this block, we need to get rid of all these. And we would want to move this to here. And in order to move this to here, we need to move all these disks to this middle stack here. So basically we need to get to this situation here. We need to take all the disks that were on top of this larger one and put them in the middle stack. And then we will be able to move this disk over here to get to this situation. So basically here we are done. We moved the larger disk here, and we only have a sub problem now. So let's label these stacks. So let's call this stack A, B, C. So in the beginning we want to find moves to move 4 disks from A to C through B. So this is disks from to through. So let's say that, so this is the function we need to implement, and we'll show that this function can be solved recursively. We know the base case, so we know how to solve 1ACB, for example. This should only output AC, that is move this disk from A to C. And they actually want us to print numbers, I guess. Yes. So we should we'd rather name these. So if you see AC here, this means 1, 3. So if we only had one disk, we'd simply move it from 1 to 3. And this is what happens actually here. So here, what we did here was to move all these disks from, so this move here is equivalent to our function f. We move 3 disks from A to B using C to get to this position. And then what we did next was to move this disk from here to here, so we performed the move A to C. So we performed the move A to C, and we got to this position. And here again, what we need to do is to move these two upper disks to here, so we could free this bottom disk. So basically what we will do is we will move 2 disks from B to A using C to get to this position. Basically we need to do this. So here was that larger disk. So we move these 2 disks from B to A to get to this position, and here we'll simply move 1 disk from B to C. So we'll move disk over here, and then we will need to recurse on this. So in order to free this disk, we'll need to move this upper disk here. So we'll have f of 1 A, B through C. So this will move this disk here. Then we will move this disk, this bottom disk from here to here. So that would be A to C. And by then this disk will be here. So the last move will be B to C. So basically, we always move all the disks that block the larger disk, to the stack that is different from our source and our destination. So if we want to solve f of n from A to C using B, so this would be equivalent to moving disks n-1 from A to B using C, and then making a move from A to C, and then again solving the problem again for n-1 B to C using A. So when we got to this position here, this one here, it's like we have the same problem again, only this time n is equal to 3. So here you can ignore this because it's not gonna ever move ever again. So you can just ignore this disk here and think of this as trying to solve the problem for n equals n-1, and our source stack here is B instead of A. So this is pretty much it, and this gives us a a way of calculating the actual number of moves we would require. So first of all, this solution, like the way we constructed it, it has to be the minimal solution. Otherwise, because all the moves we performed were forced moves, we did not have any other choice. So we had to move the larger block first, because we had to get to that configuration in all possible scenarios, and we did that optimally. So let t of n be equal to the number of moves to solve hanoi of n. Okay, so what does this formula tell us? So this tells us that this is precisely t of n is equal to t of n minus 1 plus, this is equivalent to 1 move, so plus 1 plus t of n minus 1. So this is equal to 2 t of n minus 1 plus 1. So we got a recurrence relation in terms of n. So this is 2 t of n minus 1 plus 1. And with the base case of t of 1 is equal to 1. So if we had only one disk, then we would require one move to get it to the destination, so we just move it from here to here. So if we so this way we could calculate t of 2. So this would be equal to 2 times t of 1 plus 1. So this is 3. T of 3 equals to 2 times t of 2 plus 1. So this is 7. And t of 4 would be equal to 2 times t of 3 plus 1. So this should equal 15. And if you notice here, there is a pattern that starts to become obvious. So this is like 2 to the 1 minus 1. This is 2 squared minus 1. This is 2 cubed minus 1. And this is 2 to the 4th minus 1. So basically, t of n is just equal to 2 to the n minus 1. We could prove this by induction, or we could use generating functions to actually come up with the formula. And if we check here, it matches the output, because if n is equal to 2, the number of moves would be 2 squared minus 1, which is 3. So that's valid. So this is pretty much it. Let's go ahead and code our recursive solution, and then watch an animation of the actual process of solving the towers of hanoi. Okay, so let's present the solution to this problem. Let's open our file. We'll start by reading the input, and then we will implement our recursive function. It will have the following signature. So it has 4 parameters. These are our 3 stacks, and this is the number of disks that are placed on the source stack. So this basically means that we would move n disks from source to destination using auxiliary stack. We'll start by stating our base condition. So if the number of disks is less than or equal to 0, we will just return. Then, as we said, in order to move the largest disk, we need to get rid of all disks that are on top of it. So that is to say, we need to move n-1 disks from source to auxiliary using destination. and then our largest disk will be free to move. Then we can move it from source to destination, performing our first move. So that would be this will output a move from source to destination. After this, we are left with a sub-problem that is similar to the original problem. The only difference now is that our disks are placed on the auxiliary stack instead of the source stack. So we need to solve our problem for n-1 disks placed on the auxiliary stack, and we will need to move them to the destination stack using the source stack. So that would translate to this. And this is pretty much it. So in our main function, we need to first output the number of moves, which is, as we said, just 2 to the n-1. And we calculated 2 to the n using the shift operator here. And then we'll just call our solve function with the following parameters. So we are moving n disks from stack 1 to stack 3 using stack 2. So this is it. Let's compile our program, and for 2 it should give us three moves. So that seems correct. Let's go ahead and submit. So this works. Now I'm gonna leave you with a visualization of the solving of a tower of hanoi with 8 disks. Thank you for watching. See you in the next video. Thank you.